Okay, so one of the methods in finding the perpendicular distance from a point to the plane, one method is to use vector projection. Okay. And so just to recall, say this is the plane, right? Recall that. Okay, so for example, if we want to find this A, this is B, very quickly, right? Then the projection of A onto B, like this distance, right? The green color portion, right? This is just A. The perpendicular distance is just A dot product with B hat for this distance, right? Right. So if I were to turn this around, okay, so very quickly, this is the idea that we'll be looking at. Alright, what I'm going to do is I'm going to use the plane. This is my plane. Alright, and this is my normal vector. Right, this is my normal vector. Right, and I want to find from the origin to the plane, right? So from the origin, I'm going to just choose a point on the plane here. It's going to choose it A. Alright, and after that, I'm going to find what I'm going to do. I'm going to project this. Okay, so maybe on the origin, right? The origin, I have a point maybe somewhere here. Okay, so this origin will be 0, 0, 0. Okay. Okay, so maybe this point here is 0, 0, 0. Right, 0, 0, 0. Okay, and similarly, this could be what I call maybe AO. Okay, and then after that, this is the normal vector. Right, because we are looking at a normal vector, we can easily just choose. Right, so what we're going to do is we're going to find this blue color portion to give us the answer. Right, this is the perpendicular distance from the origin to the plane. Right, and what we can actually do is we can use project our AO onto the normal vector. Okay, so meaning over here what you can do is you can actually take AO dot product with the project onto n hat unit vector for the normal vector, right, to give us the answer. Okay, so that's the general idea that we are doing here, because we just turn the whole question to our right, 90 degrees clockwise. You can see actually this is like we are actually doing a vector projection where this is the base. Okay, so next what we're going to do quickly, we first try to find, we have the point, the plane x minus 2y plus z equals to 2. You can write it any way you want. You can also write it this way. So product of 1 negative 2 1 equals to 2. Alright, and very quickly you can see what you can do is we try to first find a point that lies on the plane. Okay, so we have the point. Maybe what we can do is we can just choose maybe choose A, which is 2, 0, 0. Alright, you can verify that this is so we will guess guess on the plane, right? Lies on the plane. Okay. After that, right, so quickly, if this is my point A, 2, 0, 0, alright, I have another origin lying up there, 0, 0, 0, right? Okay, this vector here, okay, this vector here, this would just be, and then our plane is over here, right? So the normal vector, right? Okay, the normal vector here, right? So it just equals to 1, negative 2, 1. This is the normal vector, right? Okay, so very quickly, if you want to find so our normal vector is equals to 1, negative 2, 1. So suppose we want to find this yellow, this red color portion. This is actually the distance you are finding from O to the perpendicular distance from also called the ON, right? We want to find ON. We want to find the perpendicular distance, right? So actually this perpendicular distance also called this ON, right? This is nothing is equal to the projection length or projection, right, of OA, okay, of OA, or AO also can have A, okay, onto the N, right? So we're actually projecting, this vector onto the normal vector. Okay, this is how we get our answer. So actually this is nothing but taking OA dot product with the unit vector of n, give us the answer. So what is OA? OA is just 2, 0, 0, right? Dot product with unit vector of n, so our n is 1, -2, 1, right? Divided by its own magnitude, which you're going to put outside. We're going to put the magnitude outside, it's 1 over square root 4, actually 1, 2 square plus 1, actually 6, oh sorry. Okay, and this will give us 2 over square root 6, or rationalizing is square root 6 over 3 units. Okay, and that's the answer. So I say again, we're actually projecting our one vector onto the other one, n, and this unit vector here you can use it as n hat, right, since it's perpendicular to the plane. Oh,